Today's lecture is on water. And I'm sure most of you are familiar with this, and we're not going to spend much time, we're not going to spend any time talking about the hydrologic cycle. I'm going to assume that you either took the class last quarter and know about it, or you're an ESS student and know about it. But it's fairly straightforward. What we're going to talk about mainly is what we're doing to this system and what we need to change in terms of what we're doing to this system. But for those of you who are not at all familiar with that, is there anybody? Basically, we have this beautiful closed system where water continuously, like our air, circles around. So you're drinking the same water millions and millions of other life forms have used over the past 2.5 billion years or so. Now, people are concerned about how we're disrupting this very robust, very powerful, in some ways it may be the defining ecological system of the planet. So it would not be inaccurate to think of the planet as a water planet. It's mostly covered in water. Water is a distinguishing feature of this planet. Water is crucial to just about everything that transpires, from the temperature to life. It's a habitat. It's a place for transportation. But we've got all sorts of concerns. Some concerns have to do with with those regions where water is scarce and becoming scarcer. Another set of concerns has to do with those regions where water where there's a flooding problem, which seems to be getting more intense for everybody, no matter where you live. The amount of pollution in the water is remarkable. Almost every glass of water you will ever drink in your life is deeply contaminated. Now, what's it contaminated with? We'll discover there are so few things regulated in water that you are drinking steamy broth of antibiotics and birth control pills and Viagra and all sorts of medications and toxic house cleaning agents and so on that migrate into every drop of water on the planet. And we have no way, in many cases, of even removing these things. What we're not so sure about is what it means to be drinking this type of water your entire life. What does it mean? Some people are worried that some of these things, like the constant daily exposure to low levels of antibiotics, ultimately is slowly aggregating in significant public health impacts. But we have no way of regulating that. These things go, they're ingested by you, released by you, and none of the ways in which we restore water or nature restores water prove to be successful in filtering these out. So we have a whole lot of things which are now permanently in the water system. Permanently, well, that might be extreme. Maybe we will figure a way to remove these, some technology. But right now we know that every drop of water we absorb is in some way, I don't want to alarm anybody because we're talking about, in many cases, very, very small amounts, nor do we really know what their health impacts are, that we have a growing body of concern that the water we are drinking is polluted in ways which may have crossed a critical threshold. That is, we may now be starting to discern significant public health impacts related to drinking this water that has these various substances in it. So, of course, you can't escape by turning to beer or wine. There's water in those as well, ultimately. I guess wine would be pretty good. So maybe a diet of steady wine, although I don't think I should say that here. Any of you ever read The Three Musketeers when you were kids? Remember the scene when two of them get locked into a wine cellar for like 2 weeks? I probably read the abridged version where they took that out for kids, but anyways. It isn't just what's happening to the water, it's also happening what is happening to the vast, enormous, in some ways almost unimaginably immense infrastructure that transports water, that cleanses water, that removes wastewater, not just in Orange County, not just in Southern California, not just in the United States, but worldwide. We have this enormous infrastructure. And because most of the infrastructure was built when the population was considerably smaller, we are finding that in place after place around the planet, water infrastructure is being overwhelmed by demand. And so That's why cities like New York are allowed to vent raw sewage into the ocean. They're allowed to vent raw sewage into the ocean because the amount of sewage that New York sometimes produces cannot be handled by their filtration systems that exist. So they have only one choice. It'll either come back up the manholes and flood the streets of New York, or they can vent it out into the ocean. And that isn't just New York. It is cities around the world are finding their infrastructure is old and it cannot process the demands. In some cases it can't provide enough water. In other cases it cannot process wastewater quick enough. And when we look at infrastructure, we say, wow, to replace the infrastructure in a city like New York will be billions and billions and billions of dollars. So it is quite difficult to simply take a big city like that and say we're going to put in a whole new efficient water system. Some people think this is what we should be doing. This will create jobs, it'll be good for the economy, it'll pay off over the decades. Other people look at a shorter time frame and say we cannot possibly, so we're sort of stuck. We're with an infrastructure that is slowly falling apart, but we're not willing to invest in something larger or more robust. New York is a good example because it has some of this, some large water problems, but as we'll talk about later today, California's own infrastructure, that infrastructure which brought water from, through the Owens River, Owens Lake, Colorado River, these systems into Southern California, which made Los Angeles possible and made Orange County possible, are also being overwhelmed by demand. The areas are much bigger. And so we fight a battle between, can we recycle water, can we treat water quickly enough to supply the needs in a place like Orange County, which may double in size, or do we have to find more water somewhere and bring it into the system? And if we do, where is that water going to come from? So we have to either use the water we have more efficiently, or we have to bring in more water. We have a different type of problem than they have in New York, but everywhere infrastructure is, or not everywhere in the world, but almost everywhere in the world, infrastructure is slowly falling away from human needs. And so when the institutions, whatever they are, security institutions, educational institutions, healthcare institutions, water treatment facilities, waste treatment facilities, when those institutions, those practices, that infrastructure starts to no longer be able to meet demand, then you have that situation that we talked about in earlier weeks, where you have the potential for the thing to break down, to collapse. Or you've got to figure out some way to take pressure and either retrofit solutions into it or build something new, or somehow, because obviously you cannot have a situation where we get less and less water and population grows and grows. That's not sustainable for Orange County or for Los Angeles. But we cannot expect that future needs will be met just by bringing more water in through these, vast aqueduct systems that we built, stretching hundreds of miles away from where we're living. So as I say, one of the challenges for infrastructure is growing demand. We use not so much that we're actually in many ways, especially in California, we're more efficient than we've ever been in terms of water use today. So we're doing well, but we're also growing. So California as a state uses an awful lot of water, even though we're using it more and more efficiently. But in other parts of the world where there is growing demand, other parts of the world are growing in population much more quickly than we are. Africa will roughly double in size during your lifetime. And even though the average African uses something in the order of 20 liters of water a day, which is just a fraction of what we use, when you double that, that's a whole lot more water when you add 1 billion more people, even at 20 liters a day. When you have old infrastructure and more demand, you get high costs. And so people worry about how expensive water could become. And with high costs, of course, comes the threat of inequality built into the system, with rich people having fountains and golf courses and tons of water, and poor people being increasingly sort of thirsty. sewage. But for large portions of the world, venting sewage directly into the river system is the norm. And this is a big problem for, famous rivers like the Ganges, for example, where huge amounts of untreated human sewage enter the river system every day. And as we know from sort of the principle 3 of sustainability, if you put more waste into an ecosystem than it can process and assimilate and break down and neutralize, then it becomes what we consider polluted. And polluted means things like, a healthy environment for depending on the pollutant, could be protozoa, could be bacteria, could be viruses, could be all sorts of good yummy things like that. And as a result of this, it has been estimated that about 4% of public health globally is waterborne illness. And it kills an estimated 1.6 million people a year. So it's a big problem everywhere. And you have, these situations where people spend an enormous amount of time trying to obtain water in large portions of the world. Time when they're not working, when they're not producing other types of value. And when you're not producing other types of value in a poor economy, that means you're losing opportunities to increase educational skills, or improve public health, or improve whatever it is you want to improve. And you can see which parts of the world face high levels of water stress, where they are drawing down as much or more water than they have available. So, and when people are drawing down, and our guest speaker who isn't here, and if he does show up, we'll talk about what happens when, how quickly we have discovered in just the past couple of years that we may be depleting groundwater, vast, enormous groundwater reservoirs. Groundwater reservoirs that in some countries, like Pakistan, provide half of the water that the country relies on. And that we think may have taken not years or decades, but maybe millennia to fill. So those are reservoirs that you don't just deplete them, billions and billions of gallons of water, and then they fill up over the rainy season. These are things that take a long time. So as we move groundwater down, now I'm not saying that this is true of every single bit of groundwater, but large quantities of groundwater, they're now saying, are being depleted and will take an enormously long time to recharge. So we've got some problems there if this continues to drop, and yet that's what people rely on for irrigating their farmland and for the personal use and so on and so forth. And so this large water-stressed part of the planet is a great concern, and of course, it includes California, where we're drawing down a lot of water. We consume almost 4 trillion gallons of water every month, which is a lot more than the more, let's say, efficient water users on the planet. So we use a lot of water. We use a lot of water from the moment we wake up until the moment we go to sleep. We're using an awful lot of water. And and I'm going to argue over the next few minutes that this is something we need to revisit. Because one way we can take a whole lot of stress out of the system is by using water more efficiently ourselves. And if you look at how we use water, it is largely for, and often this is thermoelectric power, which is water which goes right back into the system quickly. So sometimes that's taken out. But we use a lot for irrigation. And what's important there is not that whether it returns to the system. Of course it returns to the system. It's the condition. If it returns to the system with pesticides and fertilizer and insecticides in it, then it's very different than if it returns to the system through an organic farm and it's perfectly fine. So it sort of depends what happens in these uses of it. And that's what we're going to talk about. But here's some interesting statistics. Every day, so we have these stark, powerful images of water stress and these numbers of more than 1 billion people who don't have water. But we put we put enough water to satisfy the water needs of almost everybody on the planet, just watering golf courses. So we use an awful lot of water. That is, the wealthy part of the world uses an awful lot of water, not just to drink and brush their teeth and prepare food and grow stuff, but on things like cats. Golf courses are like the human equivalent of cats. There's just way too many of them, and I'm not sure which one's more destructive of the natural environment. I know there's probably some people here who are partial to golf. There may even be people here who are partial to cats, I suspect. But take a look at some of these numbers. Golf courses, to keep them green and pristine, require an awful lot of pesticides, an awful lot of water. And some of the places in the world that have where people are struggling to get enough water each day are able to put a lot of water into the tourist sector. So if you look at Las Vegas, which has in the desert a whole lot of golf courses, the amount of water that it uses could cover 150,000 acres 2 feet deep. Graphically, it's sort of like what you guys are going to produce, but I think you'll be more sophisticated with the numbers. Because it has some interesting images, but it doesn't tell us a great deal about water. And this is one of the themes, of course, of last week and of the course, is this challenge between making things interesting and telling people information that is as high quality and as accurate and that captures the complexity of the real world with as much sort of sophistication as we can muster. And there's always a battle between sort of distorting the world to make it a story that people want to listen to and telling about the world in all its sort of mundane detail so that the account is accurate and overwhelming. So we use a lot of water for agriculture. But we use a lot of water for a whole lot of things. And agriculture is one use. And the key thing is not so much that this, one of the things that you saw in that little film, a cup of coffee takes 37 gallons of water, or a hamburger takes, whatever it is, 2,700 gallons of water. And those are sort of, in a way, meaningless numbers, because they don't really tell us very much. One of the ideas behind it is that if you don't have very much water here, and you have a ton of water here, and it takes a ton of water to raise cattle, then you're probably best off buying beef from them, because they've got tons of water, and so in a sense, for that beef, they need the 2,700 gallons to produce the beef. They've got it. You don't have it, but you can buy the beef, and that's called virtual water, and that's one of the ways water moves around the planet, is in the finished product, it can be a useful number. But of course, what's really important is what happens to that 2,700 gallons of water as it's being used. Because if it's clean water going in and clean water going out, then it doesn't matter whether it takes 8 gallons or 73 gallons to do X, if that water stays in the system. If it changes in some way, if it picks up a load of some toxic material, then we have to start worrying about that process. But when you see those big numbers, what they're really trying to communicate is that we trade water without actually moving water. We trade it by moving, in principle, by things that require a lot of water to produce. We sell the end product to places that don't have very much water, and so on. And so some economists say the world is not particularly good at that. That would be one solution to some of the water problems, would be to say to people, don't raise X here, because you don't have enough water to raise X efficiently. Buy it from over here. Buy everything from Canada, because Canada has lots of water. And don't produce anything in Southern California, because you don't have any water. So buy it from somewhere else and bring it down. Now there's other types of costs if you're not looking at water, like transportation costs and so on. But we understand the basic idea of virtual water and those numbers. But otherwise they're sort of meaningless. They're sort of meaningless because what's really interesting is all this stuff. All the ways in which water is adulterated, is transformed, is stepped up to something that not quite as pure as it was, or is it stepped down? What do you do when you're like step down water, step up water? Nobody deals water here. In any case, there's a lot of things that happen to it, and all this sort of stuff here that you're seeing, from animal waste to nuclear waste, finds its way into our water system. And historically, the quantities have been sort of small for much of the world, and we haven't thought that they were going to aggregate in us. But now we look and we sort of are starting to get information, scientific information, that, you know, things like breast milk are more contaminated as sources, you know, than people ever imagined. And so from the very time, you know, a child is born, whether it's formula or whatever else, it may be absorbing antibiotics and other types of medications. And we're starting to say, does that affect development? Does that predispose? Is there, you know, are we going to start to see more and more clear public health impacts because we have modified water and because it's now really difficult to find pure water anywhere on the planet? And what do we do about that? What do we do? Do we have to, you know, because there's literally so many things in our water supply now. But as I say, don't get alarmed, they're small quantities. But there's so many things in our water supply. So that's a big issue that we're going to be probing a little bit, as well as this issue here of you know, the sheer volume. So water is about the amount that we use to do things, how much do you need to get through your day, and the quality, what happens after you've used it. So what does it look like after it's gone through your life, after it's traveled through your life in a typical day? How much travels through your life and what does it look like? And what we discover is that most of the stuff that we add to water, whether it's toothpaste or mouth rinse or makeup remover or a cleaning agent to clean our shower stalls or toilets, most of that stuff we have no idea what its impacts are. But what we're slowly discovering is it doesn't disappear. The water goes through a, you know, a complex, a fairly rigorous process of being cleaned, where, you know, sediment is taken out and it sits there for periods of time and stuff settles and it's shocked with chlorine and it moves back into nature only after the sediment has been removed and it's been shocked with chlorine or put through some sort of reverse osmosis process. But what we're discovering is that those processes that our infrastructure is built to do quickly and efficiently may not remove a lot of the stuff that water contains. And so now we're saying, is that what does that mean? Can we develop processes of treating wastewater which remove all that stuff? Do we need to? If we need to, you know, and we don't, what will happen to us? What sort of public health challenge will we face in 40 or 50 years if we've allowed people to you know, be exposed to much higher levels of these contaminants than was the case 50 or 100 years ago, when they weren't being used nearly at the same scale that they are today? You know, partly because there's just a lot of people and they're living longer and they're putting a lot more stuff into the waste. So it's quantity and quality. This is a, you know, and the world has a trade system to try and deal with the quantity issue. And so the quantity issue we can sometimes adjust by moving finished goods from, so this is the trade in virtual water that I was talking about. The quality issue, that's a different sort of issue. And it becomes very, very big concern, a public health crisis during certain disaster moments. So we're exposed to contaminated water all the time, but it sort of peaks maybe during a flood, for example, when the system completely is overwhelmed and everybody's exposed to highly contaminated water. When we have floods, we're exposed to particularly high levels of polluted water, and often we try and, you know, deal with that, and that's a growing problem. That is, more people and plus climate change means more flooding. So we're always exposed to polluted water. In some cases, we're exposed to huge doses of polluted water. Other parts of the planet, of course, are exposed to long droughts. we've had significant droughts in Southern California, for example, just probably around the beginning of your lifetimes. The state was in a period of drought. And in the case of California, that might not have been a bad thing, in that some people link it to increased water efficiency. So some people say, well, California, especially LA, Orange County, San Diego, learned from drought experience. And they started to try to become more efficient. Now, does everybody agree with that? No. But certainly there are probably some adjustments to the water system which took place as a response to long-term drought experiences. And we know that everywhere in the world where they're experiencing longer droughts, people are finding innovative ways to try and cope with that. Some of them are good, some of them are bad. The bad ones, the big outcome that people are most talking about these days is, could the combination of polluted water and flood water and drought, could these put pressures on social systems that will ultimately cause them to resort to violence? And there's sort of two schools of thought on this question. For some people, it is inevitable. There's a book that just came out recently called, Climate Wars, and the subtitle is What People Will Die of in the 21st Century. And the author wants to argue that we will die fighting over water, or trying to get access to water, or being polluted by water. So water, which historically has been the elixir of life, will become the agent of death for your generation. Whether you're fighting over it directly to try and control access to it, or to try and protect the water supplies that you have, or whether you're just dying because it's polluted or you don't have enough of it. Now, other people think that's a bit of a grim sort of vision of the future, and they argue that faced with different types of environmental pressures, water scarcity, flooding, water pollution, the most likely response is ingenuity and innovation and collaborative types of responses. And I think this is going to be the big question for your generation in some ways, is nature is a remarkably innovative and adaptive type of system. Whatever stress you put in nature, nature finds some way to manage it, to deal with it, and to come back from it. Humans are a remarkably innovative, creative part of nature. And they're able to do amazing things that people say, this could never happen. 5 years later, it has happened. We could never be there, we get there. Nobody could ever do this, somebody does this. Human history is all about the great accomplishments of people who have decided that they could do something that other people told them was not possible to do. So we do have this stock of human ingenuity and the stock of ecological ingenuity, which if we can get them to work together, if we can sort of leverage the two things, your creativity and nature's ability to find solutions to its own challenges, then maybe we do have a bright future. And so you have one group of people saying, no, we've got a lot of ingenuity. We simply have to figure out how to leverage it to get through some of these challenges. We can't sit there and say there's nothing that can be done about poor quality water infrastructure. We're screwed. Let's just vent more sewage forever. We're going to sit there and somebody's going to say, you cannot change New York City. New York City is unchangeable. It is screwed. And then human ingenuity is going to say, actually, what if we did this? Here's a way to change New York City. And 10 years later, people will be applauding that and saying, wow, the man who saved, the woman who saved New York City. Is that going to be the future? A future built on your remarkable innovations and moments of creativity that nobody anticipated? Or are the pessimists going to be right, and it's going to be death and violence and a steady degradation of the quality of our lives as we discover more and more things closed off. Can't swim there, can't surf there, can't drink that, can't touch that, and so on. I guess nobody knows. Of course, we can certainly, like the little green men here, choose a side. We can decide whether we're going to, lock ourselves onto trajectories which are not exciting, or whether we're going to deal with these problems. And let's not be naive about the scale of some of the problems. You've probably heard about the Great Garbage Patch, and there's one in each. There's one in every oceanic gyre on the planet. And what are these great garbage patches? Well, basically, to simplify it somewhat, many forms of plastic that we use are not degradable, biodegradable. So all that can happen to them is they slowly, through maybe say wave action or whatever, break up into smaller and smaller pieces, but they never are assimilated back into the ecological system. They remain plastic forever. And they collect. People have called this different things, but it has to do probably with ocean currents and heat and cold exchange. And so they collect into these large masses. Sort of like, if you remember from lectures long ago, I think I talked about the planets forming from the debris of the universe. Well, we have these little planets of garbage that are forming in our ocean from the debris that we have scattered around. And this debris is consolidating in these masses, which some people think are enormous in terms of their mass and in terms of their volume. So they are big. The biggest one is off is 1,000 miles. Why do people look disgusted? It's 1,000 miles off the coast of California, with the world's biggest mass of churning, slowly growing garbage, and it's mostly little tiny pieces of plastic, but there are some big ugly pieces in there as well. And as it gets bigger, more big stuff gets into it. And I guess it's sort of like most islands in the past were formed by volcanic activity, sort of energy from the center of the planet being released and cooled by waters. But now human activity is going to create a whole new set of tropical islands. Islands made of simply trash. And they will consolidate. And then I suppose if you're entrepreneurial, you'll set a hotel up on them. And people can whatever they do. But obviously they'll have to be improved a little bit. Because the image on the right is not real attractive. But so a lot of the plastic that we've produced over the past few decades, we're now discovering is accumulating in the various ocean gyres, in the Atlantic gyre and the Pacific and the Indian. Every ocean has its island of plastic waste, but ours is the biggest. Ours is the most powerful. Ours is the most daunting. So we've got that issue, because one of the things that people are asking, of course, is what does it mean? I mean, is it simply a curiosity to have these vast sort of these sort of they're sort of, people think of them as cones. So they sort of have a surface area which you can sort of see, but they extend deep down into the ocean. This big cone of plastic, almost like a volcano, but it's our own waste, our own bits and pieces of waste gathering together to form new platforms for human ingenuity. But one question is does it matter, and if it does, how? And if it matters in some important way, if it's destroying sea life, or it's going to affect, ocean currents, or going to end up somehow, it's going to be evaporated into the freshwater system if the pieces get small enough, and so on. We end up drinking them all. We could end up drinking these islands down if they get smaller. So as they break up into smaller and smaller parts, we'll drink them. There's something sort of cyclical and complete about that, isn't there? So then the question is, if we discover that this is a public health risk or an ecological risk, what can we do about this? This is not where you can take a little boat and pick it up with a net. These are little tiny pieces, and billions and billions of little tiny pieces of fragments of plastic. So you can't just go and sort of clean up the ocean in a Saturday morning on Earth Day. This is a more complicated challenge. Doesn't mean we can't do something about it. And the old challenges haven't gone away. The old challenges, like what happens to still much of the world, an enormous amount of the world, water system is distorted by things like mining operations. Mining operations are particularly damaging to water system. They distort them, they change the temperature of them, they change the pathways of them, they add chemicals and other pollutants to them, and so big mining operations can produce, have enormous hydrological impacts. So plastic, plastic, mining, agriculture, all of these things are starting to come into focus as creating challenges. Now, some of them are in some ways ridiculous, like the challenge. So those islands that we talked about, they're formed from the broken up pieces of plastic, and plastic. One familiar form of plastic is the plastic water bottle. The 25 billion that we purchase as a country every single year. Now, 25 billion, that's 2.7 tons of plastic that ends up, 2.7 million tons of plastic that ends up, in places like the Pacific garbage patch. And we could probably do, it takes an awful lot of energy to produce this plastic, to grow this massive garbage patch. And what we've discovered is that a lot of the plastic water bottles that people use actually are toxic themselves. So as people become aware of this, they start to advertise, we're using PBA-free bottles, or we're using bottles that don't have some impurity. But what we're discovering is that plastic gives stuff off. It doesn't just break into little pieces, it also has a chemical aura. And when you touch it, for example, one of the biggest loads of chemical into you is when you pick up your fast food for the first time. Because the materials that they use to keep that fast food sort of together and fresh, when they're warmed up, they release chemicals that enter your skin. And so people who, now we're saying, wow, we're ingesting chemicals that we don't even know what they do. Do they affect cognitive function? Do they affect immune systems? Do they affect reproductive systems? We're not sure, but we're discovering that you don't even have to eat the fast food to be contaminated by it. Just being in the presence of fast food. Fast food is sort of like secondhand smoke. If your neighbor's eating fast food, you're being sickened by it. And I don't just mean in a metaphorical sense. I mean like those chemicals are landing on your skin in large quantities. So the plastics may be not very healthy. And then we're discovering that the water inside, in many cases, bottled water turns out to be less pure than tap water. In some cases, it turns out to be just tap water itself, but in other cases where it's taken from a spring, it turns out to be actually impure water. So we're spending tons of money polluting an ocean so that we can use things which don't just contaminate the oceans and landfills, but may actually be contaminated ourselves to get a lower quality of water most of the time. And yet we continue to. This must be one of the great scams of history, to persuade people that they need water in bottles, that somehow this is an upgrade of their lives, when almost every single bit of scientific research we have suggests that this is a mistake, that there is no way to package bottled water and make it potable. Of course, it isn't just water, it's also soda. Some people drink soda. In fact, people drink so much soda that there is an entire movement that has grown up around the world to fight soda manufacturing and bottling companies, because we are discovering that they take so much groundwater out of the system, they can actually put local villages and so on into severe water stress. And so there are large movements in countries like India to try and say, if Coca-Cola is going to set up a bottling plant in our area, it has to make sure that it doesn't reduce the amount of fresh water available to the local citizens, because that is water that's actually taken out of the system and is moving on to someplace else. And it turns out that the sheer amount of water that has been transformed into soda, into where we're actually chemicalizing the water ourselves, freely chemicalizing it, and then ingesting it, is not just a health risk, but maybe a food security issue as well. I mean, I think even a lot of fairly hardcore environmentalists accept that there's some times when bottled water makes sense. There are certain situations in which it's essential, whether it's disaster relief or what have you. During those first few weeks when you're transitioning into another country's hydrological system and stuff like that, there are times when bottled water makes sense. But it probably doesn't make sense on the scale that we're investing into it. So somewhere the point of equilibrium is not 25 billion bottles a year. Maybe it's 1 billion or half a billion or something like that, but it's not 25 billion. 25 billion is too many. So we've got to move that somewhere else, which is never, like everything in life, very few things are black and white. So to say that we could never have a legitimate use for bottled water is ridiculous. But to say that we need it every time we're thirsty. So let's just take a look at something that should put you off bottled water forever. Now I have to say, most issues have two sides, but it's hard to see the pro side of the bottled water debate. And interestingly enough, Pepsi has now invested in what may be a very valuable and important initiative. It's certainly not going to be an easy one, and that is to rebrand itself as the label that you think of when you think of nutrition. So Pepsi's new argument is that when people think of Pepsi, they think of things like soda, and they think of things like whatever else Pepsi owns, corn chips, and bottled water. And what they want you to think of is healthy, nutritious food. And so you will see, like Walmart is trying to rebrand itself, Pepsi will, in your lifetime, in the next 5 or 10 years, try to rebrand itself so that you no longer think of it as soda and chips, but you think of it as, carrot sticks and broccoli. The woman who's in charge has a TEDx talk. Her name's Dondina Bradley. She and I actually both spoke at the same event, and she admitted that she has one of the great challenges of the country, and that is to try and take a huge company and give its name a different meaning, not the soda that you need on a hot day, but nutrition. Another interesting fact is that people have calculated, and the guy who's going to be here, who isn't here, he has a major role in a very interesting documentary that's going to be released shortly called Last Call at the Oasis. And one of the things that they claim in that documentary, some of you may, did anybody see it? It was screened at UCI a few days ago. You saw it, yeah? So they point out that the cost, the amount of money we as a country spend on bottled water is roughly equal to what it would cost to rehabilitate the country's water infrastructure. So somehow somebody could figure out, we have all that money that we spend, $1 here, $2.50 there, $1.75 here, $3 there. If we could somehow aggregate that, we could completely overhaul the country's water infrastructure. So the numbers are just that close in this eerie, strange, morphic resonance type of way. Do you believe in morphic resonance? You do? I have to admit I'm on the fence, but okay. Bottled water is not the only. We find lots of other ways to misuse water, like runoff, and sometimes it's large scale. This is mining. This is industrial effluent going right into the water system, and here's a sewage system being overwhelmed by demand and popping the cover off a manhole and releasing sewage so that it can run off. It's so unpleasant when it happens. And here's our place. And one of the things that we face here is we've got this sort of these hills that lead directly down to our beautiful beaches, and we've got developments all along these hills and roads, and there is no way to stop runoff. And as a result, we're seeing the quality of our beaches sort of deteriorate as the size of our county grows. And here's a dilemma for Orange County. How do you keep it, if you believe in growth, how do you keep it growing and allow more people to live here and ensure that the economy is healthy without destroying what is arguably one of the most beautiful strips of coastline, in the world. So here you have this absolutely gorgeous area, but day after day we are saturating it with human and animal and car waste. And there's no simple solution to this. There are some things you can, but you can't, you can sort of say people shouldn't wash their cars on the street or pour oil down the gutters or something. But we don't really know how to get this. So another little challenge, because all this stuff may be feeding back. There's a nasty glass of water. Yeah, you don't want to be drinking something that's filled with those critters. Probably a few of you have. Anyways, anybody had dysentery? Nobody? You guys haven't lived. Yes, somebody has? Right? There's nothing like a good water shock to the system. Even if the water doesn't look quite as disgusting as the water this guy's drinking. There are a lot of parts of the world where the runoff and the effluent and the waste that goes into water is overwhelming, but people still use it. People are still compelled to use it, whether it's for religious reasons or work reasons or bathing or so on. And this is some nasty water. And the cumulative. There's Imperial Beach, and she is going and telling these surfers not to surf. And to respect these signs. I think this is. I don't know if this is going to prove, as research improves, if we're going to say, we raised alarms unnecessarily. That long-term, lifelong exposure to small doses of. The big concerns are birth control pills, antibiotics. It's the constant exposure to these that people are most worried about. And we may discover that they have no effect on your generation. If they do, it'll be your generation that will identify the effects in. So I'm not trying to cheer you up. I mean, but so in a sense, you are the canaries, and wool will be better when we figure it all out. Yeah. So we have these various concerns. We have, we use a ton of water. We use it inefficiently. We have infrastructure which can't manage wastewater well, and in many cases can't provide fresh water well. We make some possibly irrational decisions, like buying billions and billions of dollars of bottled water, when most sort of rational actor type models of how decisions ought to be made would suggest that we could use that money more effectively in all sorts of ways. If we took that $25 billion of the bottled water business and put it somewhere else, we couldn't use it worse. There's almost no worse way we could invest that money into water. Almost anything else we could do with water would be better. So how did we get into the situation where we're spending where we're saying the same, but we can't afford to overhaul the infrastructure of our big cities, but at the same time we're sucking down bottled water on sort of epic scales. So we've got the traditional problems growing, like continuing runoff into our coastal waters and our lakes and big mining operations. This is the beauty of a mining operation in Montana, and we have some new concerns about water. That is the big trash islands that are taking shape in the oceans, and this very recent concern that we're all drinking contaminated water continuously through our lives. So what do? So we can join the growing movement that has taken root in Europe, where it is now, in many parts of Europe, you would look really less than hip if you ordered bottled water in a restaurant. So if you want to be a trendsetter, you explicitly ask for tap water. You want tap water. This is not something that you're going to settle for tap water. So one thing we can all do easily is, and curiously, tap water in much of the world is actually quite pure. So it isn't just in North America. It's throughout much of the world. Tap water is of very high quality. And one of the good things about water is that if it's of high quality, you can drink it safely just about anywhere. Now, I'm not suggesting that you can go to Freetown or Bangui and trust the local tap water. That would be bad. Even a little bit of exposure. I can say from personal experience of being hospitalized by waterborne illness in Sierra Leone. Yes, a little exposure can be a bad thing for the weak Western metabolism. But in much of the world, you can just ask for tap water. And that already could potentially reduce the impact on those great patches of garbage in a sort of measurable way. And free up all that additional capital for investing in something that we actually attach greater value to. Another thing you can do, of course, is your own personal inventory. Households are notoriously inefficient. Things leak and people let them leak forever. Things don't work well and people allow that to happen because they don't really see the cost mounting. It's a few cents here, a few dollars there. They look and they say, this will cost $200 to have this faucet fixed, so I'll just let it drip. I'll let it drip for month after month after month. But if we went around and we installed higher efficiency shower heads and we improved and we stopped leaks throughout our infrastructure and we moved to more water efficient and energy efficient appliances, the savings that we could have there by doing this are enormous. We can go beyond that and start to introduce new technologies, new off-the-shelf technologies. For example, a very inexpensive system that probably every household should have is one that moves, some fairly benign forms of gray water into areas like your septic system, so that the water gets used twice rather than just once, and there's no real reason not to use it twice in this particular capacity. We can get more elaborate and start to really sort of retrofit things with more efficient types of systems, or invest in. You have the beautiful opportunity to decide that you want housing that has that maybe doesn't have a 3-car garage, but has a smaller garage and a gray water treatment system. I mean, those are the sort of trade-offs you'll get to make. You can say, I want the 2,500 square foot house with 3-car garage, or I want the 2,000 square foot house with a 2-car garage and a gray water treatment system. And the prices will be the same, but you guys can make that decision. You can move away from the things that add to the cost of construction today and ask for different things to add to the cost of your construction. You can say, it's going to matter to me what the building materials are and what the orientation of the house is and what sort of insulation it has and what sort of landscaping it has and how it uses water and how it uses energy. So we can all do those things. And we can do simple things. They're not always, one of the outputs of a lot of the research that I've done has shown that water catchment is something that works almost everywhere in the world where there's rain, is almost done nowhere in the world, and provides a huge stock of water that can be used for all sorts of things. Why do we need to turn on a hose to water our water when we could simply use natural rainwater to water our gardens and so on? All we need to do is create a system where that becomes possible, and that's an inexpensive, storage system, a system that you can store water safely for months you know, in the right system, and then you have access to it for a whole lot of purposes, rather than having to bring it in from the Colorado River, or use up groundwater, or hope that there's going to be a lot of snow in the you know, Sierra Nevada or something like that. And if we do that, people estimate that right now, over the next few years, we could see this enormous amount of pressure taken off the water system by changing behaviors over which we all have control. So everybody can decide to drink tap water. Everybody can decide to put an efficient shower head on. Everybody can decide to, you know, use less water for doing the various things that we do, to use up, you know, whatever it is, 175 gallons a day or something like that. And we can get more elaborate systems, and these elaborate systems are no longer, they're not daunting to your generation. They're no more complicated than you know, figuring out the next version of something like Gmail, you know. So, and I bet a lot of you have figured out Gmail. I know I have. And you can figure out this as well. And we have to decide whether these, you know, I know this is Tustin, and I know this is beautiful, but is this the way we want water used in our communities? If we're living in a sort of, you know, desert-like community, is it an important value of ours to have a huge amount of water running through a process which contaminates it and feeds it back into the hydrological system, more contaminated than most other uses of water? Or do we want to think of, maybe not, do we get rid of the game of golf, although I can see no downside to that, but do we want to, you know, transform what we think of? Does golf have to be like walking through a garden of fountains? Couldn't be played on like a sandy, arid type of thing? I mean, you know, couldn't a golfer be a bit tougher, a little bit, you know, tougher, sort of able to deal with a little bit more resistance than just driving a kid's buggy around on a big green carpet? I mean, let's man up, golfers. We can change our diets. That will have a big impact as well. You know, we can go to the low water diet. The low water diet turns out to be, strangely, a really healthy diet. So as we move towards a lower water diet, we also may be doing, you know, and here we have two pictures. I'm sure you recognize it, that's California. But we can move away from this very inefficient and costly forms of irrigation, which cause long-term problems, towards very, very efficient forms of irrigation. We can demand that our government do better. Our government, the EPA, is the milquetoast of agencies. And there's a sort of attitude in government that, well, environmental protection agencies are always sort of weak and deferential because, you know, they got to sit in the same room with the guys who are saying, I'm managing the economy, and I'm managing national security, and I'm managing public health, and I'm managing education, and I'm protecting Yosemite. And so they always feel sort of like they're the small guys at the table, and they're sort of lucky to be able to sit there. Why? They too have to man up and start. The EPA stops almost nothing, bans almost nothing, does almost nothing. The EPA can be pushed over and pushed around by anybody in government. And it's the same at the international level. The UN Environmental Program is the weak program compared to the development program or the World Bank or even something like UNICEF. That doesn't. Our priorities do not have to be that we these government agencies, because they were powerful and important 50 years ago, have to continue to be the most powerful and important ones. We can decide that actually the EPA ought to be strong. 20 years ago, after the first Rio, the U.S. tried to elevate the EPA to a cabinet level type of position, and it got pushback. But the idea was this is important, and it has to be treated with the same level of respect as other parts of government. It isn't sort of, when we've dealt with the needs of defense and we've dealt with the needs of state and we've dealt with the needs of agriculture, then we get to the EPA and see what you guys are squawking on about. We can elevate this to a higher level. We can give it some backbone and some guts and probably some funding. We can support innovation. Here's a really cool innovation. Now there's a guy who, the system is structured one way. This is how we test water. Environmental protection agencies are geared to doing that. Health agencies are geared to doing that. And as he points out, it doesn't work. People die as a result. So he sat down and figured out a cheap, quick way which potentially, if this is realized, will make an enormous difference in our ability to instantly determine whether water can be used or not. And those are the sort of things that you can do over the next few years of your lives.